Good morning, everyone, and welcome. I'm Peter Murray, Curator-in-Chief at NLA, and for this morning's discussion, Hor Lee have brought together speakers to discuss Timber Square, which is a new net zero carbon scheme in Southwark, which has just got planning approval. The scheme aims to be the largest commercial development in the UK to use cross-laminated timber. And of course, net zero is a core focus of our programme here at NLA. I'm really delighted to be chairing this session. So we'll be hearing from members of the project team about their contributions to the scheme and how they are working together towards net zero carbon. And before we start, as usual, I'd like to remind you that there will be time to ask some questions to our speakers at the end. So please do post your questions using the normal Zoom Q&A button on your screen. So to start us off, I'm very pleased to introduce Robert Hume, who's the Development Director at Landsec, and he's going to be talking about Landsec sustainability strategy, targets and their ambitions for Timber Square. Rob.
Thank you, Peter. Very proud to be here today as the Landsec Development Director responsible for Timber Square, which is a pioneering development, as you say, for net zero carbon commercial development in the UK. The development has been recognised as an exemplar case study by the World Green Building Council, the UK Green Building Council, and by NLA itself. If you can move on to the next slide, please, Molly. Now, global pandemics may come and go, but open a newspaper and there's been one issue that's been inescapable in recent years, and that's climate change. Last week was no exception. I'm sure you're aware that last Thursday, at a summit of 40 global leaders, President Biden committed the US to halve its carbon emissions within a decade compared with 2005 levels, with many others pledging to follow suit. And on Saturday, the Times was suggesting that its readers should reassess and adjust their diets to reduce their own personal carbon footprints. Climate change is a serious and far-reaching issue. It affects everyone, and it requires an urgent response. And as this slide shows, construction and the built environment is a major contributor to CO2 emissions worldwide and in the UK. 45% of UK emissions come from the built environment, with around 10% directly associated with construction. The government's already committed to the UK becoming carbon zero by 2050. And last week, Boris Johnson announced his intention to accelerate decarbonisation by targeting a 78% cut in emissions from 1990 levels by 2035. Against this backdrop, the property industry has to respond, because it's clear that we'll never achieve the reductions required if we go on building in the way we always have. Next slide, please. Sustainability is already embedded front and centre in our thinking at Landsec. Last year, we refreshed our purpose and core strategy, and underpinning this is our commitment to be sustainable. We understand the issue, and we embarked some time ago on a process to ensure that all our developments will ultimately become net zero carbon in line with the targets we've set ourselves. This is our key focus and links with our other two core purposes: connecting local communities and providing our customers, partners and people with the best platform to realise their full potential. Next slide, please. Our sustainability strategy is divided into three core areas: creating jobs and opportunities, using natural resources efficiently, and sustainable development and innovation. For each core area, we set ourselves clear and stretching targets. Next slide, please. Our credentials as a sustainable developer and property owner have become widely recognised. In 2016, we became the first commercial real estate company in the world to set a science-based carbon reduction target, which was to reduce carbon intensity by 40% by 2030. And last year, we achieved this target 11 years early. So we've set ourselves a new target of a 70% reduction from a 2014 baseline by 2030. But whilst we're seen as an industry leader on sustainable development, there's always more that can be done. Next slide, please. So why are we doing all this? Well, put simply, because the drivers for sustainability are intensifying all the time. And these drivers are from four main quarters. Firstly, investors. Financial institutions are demanding that companies take action on climate change. Between 2012 and 2019, there was a 60% increase in ESG funds, and this is only going to grow going forward. Investors are looking to follow companies that do well as well as make a profit. Sorry, that do good as well as make a profit. In terms of our customers, 126 of our existing customers and many of our potential occupiers have set their own science-based targets or made sustainability commitments, and we need to help them meet these. By offering a building that ticks all the net zero carbon boxes, they'll avoid the need for costly changes to their plans when tighter restrictions come into place. And more directly, a JLL report last year indicated that sustainable buildings command a rental premium of between 6 and 11% across central London, and they also let very much faster. Overall, in terms of employees, employees want to work for businesses that have the same values as them. 75% of employees interviewed by the Edelman Trust Barometer last year felt that businesses could be a force for good whilst also making a profit. And 2/3 of the public want to buy products that stand by their values. So this all runs deep, and the government has responded and I think gets the message on sustainability and climate change. I've already referred to the tightening of the target, or the enhanced target that was announced last week, of 78% cut by 2035. And this is likely to be enforced by the introduction of a carbon tax in future years. There's also a requirement coming in next year for reporting from all listed companies on climate-related financial disclosures. So for us, the cost of inaction would be very high, and also it would be high for our customers. Next slide, please. So we've identified 5 key steps to achieve net zero carbon. We aim to reduce operational energy use in our developments, purchase renewable energy, use an internal price of carbon to drive investment towards cleaner alternatives, reduce construction impacts through clever design specification and repositioning our assets, and also to offset remaining carbon for non-renewable energy use. To implement these steps, we have a sustainability brief, which we give to all our customers across all our developments. Signing up to our sustainability and community charters is a normal part of our process. Next slide, please. So for Timber Square, we selected a professional team who demonstrated a high level of expertise in sustainable design and asked them to come up with a scheme that responded to our net zero carbon aspirations and targets. The brief was focused on 4 main requirements, and these were to minimize embodied carbon from construction by building light and dry, retaining as much of the existing structure as possible, to minimize energy and carbon in operation through specific design of a zero carbon scheme with minimal energy demand, by delivering a human-centric design that embedded natural elements within the scheme and promoted physical activity through the building, and finally to deliver a resilient, lasting design, a strategy and a design that would allow the building to be adaptable to future uses and climates. Timber Square is a hugely exciting project, which is, I believe, going to take sustainable development to another level. I'm going to hand you back now to Peter Fisher and the rest of the team to tell you how they've addressed our brief.
Great, thank you very much, Rob. And so now we're going to hear about how the brief has informed the design and how the team has worked collaboratively to focus on a human-centric, low climate impact workplace, as well as a well-connected public realm. And so I'm very pleased to introduce Peter Fisher. He's the director at Bennett's Associates. And of course, Bennett's have been leading the field really in sustainable design since the 1990s. Peter.
Thank you. Next slide, please. Rob has started by outlining the brief, and I have to say, in all of the years that we've been working on projects of this ilk, the brief that we got from Landsec was the best one that we've ever received, and it was the best one because of its simplicity and its clarity. The sustainability brief was actually a single sheet of A4 paper with clear targets on it, and I think importantly, a clear understanding of the ramifications of some of those things. And I think one of the bits that most excited us was a combination of an emphasis on reuse and timber, and also a line that always stuck in my mind, which was visible and reversible structural joints, which implied to us that Landsec understood what the ramifications of that might be. And Rob has run through the brief that we were given, and I think we took away from that a number of factors on sustainability. I think the key items were around climate action, particularly science-based targets, the resource use and circularity, and an understanding of what that implied, but then also health and well-being. And I think the bit that really crystallized for us was a convergence of several different strands of thought around sustainability, the changing nature of the workplace, and also the way that we constructed the project, design for manufacture and assembly. And we're at about 85% DFMA working with Laing O'Rourke. And we were very interested in the intersections between these different facets and how they mutually reinforced and supported each other. The next slide, please. So just quickly looking at the location, it's in Southwark to the south of the Tate, with the more established Bankside, if you like, to the northern side, and then Union Street and railway arches to the south. So it's quite an interesting area that's overlapping between more vibrant areas and more established ones. And then on the next slide, this just begins to describe some of the very key design moves that were made. And starting from the left-hand side, there's an existing 1950s print works, which is incredibly robust on the site. And we've been able to retain about 85% of the structure of that. So we're removing some areas that are illustrated in pink. Retaining that building and combined with the hybrid structure means that the number of truck movements is almost half what we'd expect with a scheme of this scale ordinarily. Then the print works is being extended as indicated in blue, and then there is an entirely new building which is slightly taller. The buildings are roughly the same size in scale. And between those, that then creates quite a large area of public realm facing south and against the railway arches. And then one of the most important features, I think, of the building expressively has been roof terraces and balconies. Virtually every floor has access to several roof terraces, and there are 4 major roof terraces, 2 on each building. And then on the next slide, this is then the images cutting through the 2 main buildings. You can see on the left-hand side the refurbished and extended printworks, and then the entirely new ink building, as it's called. One is an atrium building, which is a virtue of the existing building itself, and then the other building is a centre core. But both of them are built with a timber hybrid structure. The most important factors, I think, on reducing energy consumption and embodied carbon across the building have been, and Dee and Francis will go into a lot more detail on each of these, but design for performance was extremely important for the project in enabling us to optimize the facade ratios, to have very good daylighting, and that morphs as we move around the building. And then on embodied carbon, as said, the use of the existing building, the hybrid structure using steel and CLT, but then importantly, I think one of the most important bits has been very, very detailed measurement of that. And the project runs what we've called a VE, carbon VE tracker, which runs along the cost VE tracker. It's done in exactly the same way. So that is tracked all the way through the project at each DTM. And if we move on to the next slide, this is then showing the way in which the DFP model was really used to try and optimize the facade ratios. And these change quite significantly as you move around the building. And it leads to some results that were, I think, conventionally are perhaps slightly surprising, in that we have very, very high glazing ratios on the northern portions of the building. So they're approaching 80%. And then the modular format of the cladding allows us to begin inserting solid, translucent, and even potentially in the future opening lights within those each of those areas. And so that morphs as we move around from 80% to 60% on the east and west facades, and then at the upper levels of the south facade that changes to 40%. So it's been very important for us manipulating glazing ratios as we move around. And then if we move on to the next slide, please. This is then beginning to show the structure, which Dee will run through in a lot more detail, but it's broadly the same across the two buildings. The existing building is much deeper plan, so it's got taller floor-to-floor heights and a much lighter weight steel structure. And between them, the two schemes are between 20 and 25% roughly lighter than a more conventional building would be. And there are no exposed surfaces, no ceilings, it's all exposed surfaces within there. And there's very much been an attitude of materials being self-finished. We're exposing the structure, we're exposing the structure of the cores. So as much as possible, it's been removing material. And it's surprising things such as steel ceilings that you would ordinarily have in such buildings. That can be about 10% of the overall embodied carbon of the project. So there's been an emphasis on reused, self-finished and recycled materials and low VOC materials, which leads to a palette a little bit like the one that that is indicated here. And I think if we move on to the next slide, which is then some of the internal views of the project, I think that part of what excites us as architects is not just exceptional carbon accountancy, if you like, and reducing the carbon impact of the building, but I think that emphasis on reuse, the idiosyncrasies that sometimes come with reuse, and then the range of different spaces that you get from the image on the top left of this, which is one of the main floor plates with the steel structure and the CLT planks all exposed to entirely timber structures on towards the top of the buildings, and then some of the reuse spaces below. I think you get a much greater spatial diversity and a material richness, and I think just an enjoyment that comes out of this that is significantly better than office buildings that were being designed 10 or so years ago. And then if we go to the next and the final slide, this then is just showing some of the external views of that, of the scheme, the public realm at the lower levels, the railway arches, and then the facades on the new buildings, where it's actually not that easy to detect the way in which the glazing ratios are altering as you move around and up the building, but they are there, and you can also see some of the terraces and the balconies on this. So with that, I will hand over to Dee. Thank you.
Thank you very much, Peter. And yes, as Peter says, our next speaker is Dee Voden. She's an associate at Untitled Steel and will be discussing engineering development of the CLT and Steel Hybrid. She'll talk about the key structural moves as well as how the team minimized embodied carbon. Dee, over to you.
Thank you very much, Peter. Next slide, please. So we were initially approached by Landsec at the beginning of 2019 about the project, and I can remember that we were really excited to be involved. The client's aspirations for the project really reflected our current thinking and our approach to low embodied carbon design. The interview process was very interesting, and Landsec gave us a brief, and using a format called Engineering Without Architecture, they asked us to go away and come up with an innovative scheme for the site, away from the rest of the design team, just out on our own. And now, like Peter, we took away 3 key points from the initial brief, and that was low embodied carbon, DFMA, and the future workplace. Now, at the time, we were working on a lot of big fit-out projects, where the tenants were making quite significant and often very unsustainable alterations to base build structures. And it was really important to us to come up with a structure that was going to be more easy to modify and offer future flexibility. And that really influenced our key design principles that we set out at the start for the scheme and our project. The image that's on the screen at the moment was from our first interview with Landsec. And looking back on it, it's really nice to see that a lot of our initial ideas are still in the scheme today. Next slide, please. So the most sustainable thing to do would be to obviously retain all of the existing buildings on the site. But our initial site appraisal showed that there was one quite small, poor quality building, I should say, on the site, and one other fantastic building that had a really generous structural grid and great floor to ceiling heights. And that's really where the refurbishment and then new build structure came from. Next slide, please. So the existing building structural grid is 6 by 12, and we needed to come up with a structural scheme that was going to work with the long spans and also be lightweight to keep the load on the existing structure to a minimum. Concrete was going to be too heavy and also really tricky to modify. And the long spans didn't really suit a glulam structure, as the beams were going to be really large and we were requiring additional transfers. So quite quickly, we kind of honed in on the steel and CLT hybrid solution. The west building actually really suited the same structural grid as the east. And so we ended up with a really similar kind of structure for both. The 6 meter spans really worked with the efficiencies of the CLT, and the steel suited the long spans. Next slide, please. Oh, I should say on that slide, those were the final solutions that we came up with. On the ink building, we ended up with cellular beams, and then on the print, we had slightly deeper, really efficient steel trusses. Next slide, please, Molly. Thank you. So the steel and CLT hybrid really kind of met the key design principles that we had set out at the start of the project. It was essentially a kit of parts which was easy to build, modify, and reuse. It offered really high levels of DFMA, and it had a low embodied carbon, particularly when compared to a traditional composite structure, which we were using for our benchmarking. Next slide, please. So like any refurbishment project, at the start, it's really important to thoroughly research and investigate the existing building to build up a detailed understanding of the structure. We were able to prove that the existing building had been designed for really high imposed loads, and we were kind of able to influence the design of the new superstructure and grid to really work with the existing structure and minimize the amount of strengthening to the frame and foundations. The approach to the print building has really been, as Peter said, to retain and reuse as much of the structure as possible. And we've actually been able to keep over 85% of the floor plates, which is very good. By limiting the amount of significant alterations to the lower floors and retaining as much structure as possible, the print building has ended up with a really low embodied carbon rate. And that's really helped to offset the much higher cost of the ink building when we're looking at the development as a whole. Next slide, please. So I think we all know that to be really sustainable, you want to avoid a new basement. And we did look at that initially on the ink building, but it was not going to be viable. So instead, we tried to make sure that the substructure design was as efficient as possible. The good ground was at a depth of a double height basement. So the basement was set at that level, and we used a piled raft solution, which really minimized the amount of piles that were needed. Early stages, we looked at a lot of different options for the stability on the ink building. And we did start out with steel perimeter bracing, which allowed a soft core to be used and really offered a lot of flexibility. But as the design progressed, we moved towards a concrete core. And this is now going to be formed in twin wall to really maximize DFMA. Early contractor involvement was really beneficial on the project, and understanding how the steelwork was going to be procured really allowed us to target VE opportunities for the steel frame. Working with the fabricator, we actually identified that there was 320 tons of BOF steelwork, which has a higher embodied carbon rate than EAF steelwork. So reducing that and working on other VE opportunities on the steel frame, we actually reduced the embodied carbon of the steel by 750 tons on the ink building alone. The ink building has been designed for 4 additional stories. That's come at a cost of 200 tons of carbon, but offers a lot of future flexibility, be that adding floors in the future or changing floor construction, and is actually only 2% of the total embodied carbon for the building. Next slide, please. So this graph shows the embodied carbon per meter squared of the structure. As we said earlier, the print building's got a really low rate, and that's owing to the amount of structure that we've been able to retain. The West building is a lot higher, but actually that figure is really good for a new build high rise with a double basement. And when we combine those buildings together and consider them as a whole, we're just above the LETI 2030 target for structure. And we've kept sequestration below the line. So actually, if we were able to include that, we're sitting below that target. Next slide, please. So the heavy hitters. So the steel frame and basement actually take up 80% of the total embodied carbon for the development. The substructure for the ink building is actually comparable to the total embodied carbon on the frame. And if we're really serious about reducing embodied carbon on structures, basements has got to be a focus of our energies, and limiting the size and depth of basements needs to be something that we're looking at, and that might come at a cost to GIA as plant has to move out of the basement, but that's something that we've got to all be considering. And on that plant related note, I'm going to hand over to Hawley and Francis.
Thank you very much. And now our next speaker, as you said, is from Hawley, and we've got Francis Brown, who's a senior associate and who's going to summarize the approach to design for performance and reducing carbon through the whole project lifecycle. Francis, over to you.
Thank you, Peter. So Hawley have got a wide range of responsibilities on the project, but for the sake of this, I'm focusing on the operational energy side, and then a little bit about enabling CLT. So for Timber Square, next slide. For Timber Square, we've used a design for performance approach. So Design for Performance is an industry initiative with the Better Buildings Partnership that aims to improve the energy performance of the office sector in the UK by setting energy targets in energy consumed per square metre per year during the building's actual operations. And that's the important point. Whilst we're talking about the modelling we've been doing during design, this is really about what it's actually going to do and be measured to do later on. So we've undertaken advanced energy modelling so far. So this is far beyond the Part L requirement for modelling that's traditionally done. During the design stage, so to better understand how the building will actually perform. So this is to help us to make decisions that will have real impacts rather than what we perceive to be something that's going to improve. So from you can see on my slides here, I've got a sort of an early stage model and then a detailed model. This is just to show how the model exists from the start, and it's the same model, but it gets evolved. So we don't just evolve the geometry, but we also, as we develop the systems and make decisions about how we're going to control them, that information goes into the model too. So from the beginning of the project, whilst the architectural design was still in development, the modelling was used to enable a science-based approach to the building design. Throughout the project stages, more information and detail was added, which enabled the team to understand the impact like never before, and has led to a much more considered approach to making decisions. Sometimes we've even been revisiting options as we make other decisions because they impact one another, something we've never been able to see before. Next slide, please. So here's an example of an early stage study. So Peter talked about this a little bit earlier on. This has had a positive impact on the building from both energy use point of view and also from a human-centred design approach. There's quite a lot of modelling behind this. So we looked at the facades design early in the process, as it's a huge impact on the way the building's going to perform. The aim here was to find the optimum design. So we wanted to minimise the energy you needed for heating and cooling the building, but we also wanted to provide good levels of daylight and actually benefit from beneficial heat gains in the winter. So you can see on the image on the right, this was these were the little models that we made to communicate the results, because as you can imagine, the data got quite unwieldy when we were looking at every little module around all the facades. But you can see on there, the bigger the squares on that model, the bigger the optimum ratio. So as Peter said earlier on, there are different sizes of windows that make sense on each facade, and also they're different from up and down the building. Clearly, if you make them too small, you lose the benefit of daylight, and that also impacts the energy. And that's something we were able to see through our design for performance modelling. So I'm not going to go into the MEP too much, but we did take a fully integrated design approach to develop the in-depth model. So that's with the modelers and the people developing the MEP design to establish the best approach. I mean, as in summary, the building, sorry, I should have said next slide. The buildings are all electric in response to the carbon benefits. They've got 4 pipe air source heat pumps for each building, and heating and cooling to the workplace is provided through a fan coil system, which was determined through actually looking at all of the different parameters to see where the best energy performance came from. And although I think active chill beams were a front runner for a while, once we looked at the different supply temperatures from the air handling units, that changed. So this is how we were sort of learning through this. So after the initial facade study, here's a list of a few of the studies that we looked at. So different air supply temperatures and specific fan powers from the air handling units, the selection criteria for the air source heat pumps, comparison of chill beams against fan units, as I just said, and also an option study for mixed mode ventilation. So that's to look at a future scenario. And actually the impact of specific controls regimes, which you would never have looked at before if you weren't doing design for performance. So some of that has actually made it into the descriptions of how the system should operate. And we actually found that these were all interrelated. In addition to this, Landsec are also targeting high standards of health and well-being. So the modelling is also used to enhance that too, as I was talking about earlier on. Next slide, please. So just to touch on embodied carbon, to support HTS and Bennett in developing their approach to embodied carbon, Hawley have been undertaking a thorough embodied carbon study at each design stage, and through stage 4 we've been maintaining a sort of like a VE tracker, so that we can keep track and make sure that design decisions are going in the right direction for embodied carbon rather than losing all the ground that's already covered. And as Dee already said, that's actually got better through stage 4. So to enable, obviously the biggest, next slide, please. Obviously one of the key things that's been done in this project is that the slabs being CLT. So from Hawley's point of view, this offered a few challenges to help the design team get through. The 2 main challenges for Hawley were acoustics and fire. So CLT, sorry, next slide, please. CLT has different acoustic properties compared to the more traditional structures. Therefore, our acoustics team have undertaken detailed calculations and testing to establish what was needed to achieve the required standards. The solution proposed is to use high-density board beneath the floor to provide acoustic density required. The design team have worked with the supply chain to establish a method for applying this whilst maintaining the overall buildability and cost. And that's led to a DFMA approach for this, with the acoustic board being integrated onto the CLT board before it comes to site. Next slide, please. So the other one is the fire, which is obviously the biggest concern for many people when you look at building out of wood. So this has been thoroughly investigated for this project. The principle of using CLT for these buildings is that the building maintains enough structural integrity in the event of a fire and therefore doesn't cause additional safety risk for the building occupants or anyone else. Hawley's fire team undertook extensive modelling to prove that any fire would burn out on its own, with the CLT self-extinguishing before it's lost its structural integrity. However, due to what was at stake, it was decided that it would be best to build a mock-up and burn it to prove the calculations. So last winter in Lyon, this happened. Next click. So we built a mock-up and set it on fire. And then this happened. Next click. After 4 hours. So 4 hours later, without any external intervention to put the fire out, despite some local delamination of the CLT surface, the ceiling self-extinguished and the burnout was achieved. This provided evidence that the calculations were accurate and that the CLT solution proposed in this instance is suitable for use in these buildings from a fire perspective. Okay, that's me done. So,
Great, thank you very much. Well, really interesting test there. So good to see that. Now we're going to move now to a bit of a panel discussion, and Tom Watson, who's the project director at Hayden Tillett Steel, is going to join us. And so please do, members of the audience, put your questions into the Q&A box. There's not many there at the moment, but I see they're starting to come in already. So thank you very much. So I'd like to just start with a bit of discussion about the brief, because Peter said to you, Rob, that this was one of the best briefs he had ever received for such a project. So how important is it that the client sets a sort of ambitious sustainability brief from the outset? And I mean, how did you develop that, Rob? Do you have your own internal team to help you with sustainability issues, or how did it come about?
Yes, we have a full sustainability team, which works hand in glove with the development teams and our project managers. So at the outset, we would bring in that team to advise on the brief and set a clear direction, with full involvement from that sustainability group. So, Peter, you don't find that clients are generally quite so well versed in these issues as Landsec obviously is?
Some are, but this was just a very clear brief. And I think one of the things that was very good about the brief that we got was the narrative behind it, and the fact it was very short. Often they become quite tick boxy, very, very dense, 100-page documents around development briefs and sustainability briefs. And this was literally a single sheet of A4 that clearly set out an agenda in a way. To an extent, the targets themselves, I think, were less relevant. It was the communicating of a clear agenda that was the most important bit behind that. And I think, as I said at one point, the implication that there was an understanding around some of the implications of that ambition. around structural types of connections, what a building might look like or feel like.
Okay. So Francis, I think perhaps this is one for you. I mean, now our whole life carbon assessments likely to become more common in the future, and could smaller scale projects be assessed soon as well?
I think absolutely, Peter. I think the days of not thinking about the whole life of the building are going to be over soon. I think now that the capability is there and the will from the industry, that this is going to become an essential part of making sure a building is actually viable.
Yeah. And so, Dee, can I ask you, I mean, what are sort of lessons from the design for performance process, do you think, on this project?
Peter, is that a question for Francis at Hawley?
Well, I was going to, well, okay, if that one you would like to answer, Francis.
Sorry, what was that about the design for performance?
Yes, what are some of the lessons from the design for performance process?
Yes, so that one, I think it's really interesting. Obviously, we as engineers love a bit of data to help us understand things better. And I think for me, so it was just that to achieve better design performance, you're not looking at finding a thing that makes your building better than the others. You're looking at doing everything a little bit better and making your decisions a little bit better in every different aspect of the project, and looking at how how it relates to each other and whether anything is tripping each other up. I think that's one of the lessons for us, is just that having more detail means that you can do everything better. In addition, I think that it's about, I think in the long run, which can't be necessarily done on one project, it's going to change the way we think about what performance is. So traditionally for engineers, performance is making sure that you've got enough heat and enough cooling and enough power for the building to make sure it can do everything that the client or the occupier wants. But that's led to a different way of sizing equipment from what you could now do. Now we're using more advanced modelling to design it so that it's not just about having enough cooling, it's about making sure it's not going to exceed your targets for operational energy. So for example, if you can actually look more closely about whether you're sizing, what is your biggest risk, I suppose, is the question. Is your biggest risk that you're going to spend too much energy, or is your biggest risk that it might get a degree cooler than you wished? And I think that sort of thing will change over the years.
Thank you very much. But just before we go to the Q&A box, perhaps the HTS team could, I mean, are you working a lot of other CLT buildings at the moment in the office?
Thanks, Peter. Yes, we are actually, and we're proposing CLT, hybrid structures, and also full timber structures, glue-down beams and CLT on pretty much every single commercial job at the moment. So it's an exciting time for us. There's obviously lots of learning to be done, and we've gone through a lot of that on this project. Our own office, we've done an extension to an office which we're moving into in the summer, and that's the CLT hybrid structure as well, with a glue-lam and CLT roof. So we've used that as a little bit of a test bed as well. So I think we're going to be seeing a lot more of these types of structures in the near future to try and meet these embodied carbon targets, which are very challenging.
Great, thank you very much. Now we've got questions now coming into fast into the Q&A box. So Seb Land-Lomas is asking, has the DFP process and Landsec's 2030 targets required any discussion and questioning of BCO requirements versus the benefits of alternative thermal expectations for reducing emissions? So who would like to answer that one?
That sounds like it might be for me.
Okay, right.
Unless Rob wants to answer it. No, okay.
I'm happy for you to.
I think, yeah, that's kind of what I was getting at just now when I was talking about what to learn from design for performance. The answer is yes, it has led us to challenge the requirements in, say, BCO standards, but also Landsec standards for the occupiers. On this project, we haven't really gone too far in relaxing them, but that's because we're at a stage where we're the first lot of projects going through this. But I do think that with the evidence you get from design for performance, and especially once you've got something in operation, because with this project you've got a higher level of metering when the building's actually completed, so you will be able to see more about the impact. And obviously we could. Our Landsec could look at different temperatures and see how it impacts people and weigh that up against the energy use, which could inform future projects, I would have thought.
Rob, do you want to add anything on the reference to BCO? And
not really. I think Francis has covered it. I mean, Landsec standards are normally sort of in excess of BCO standards. So, we had regard to those parameters when setting the brief. But yeah, nothing really particularly to challenge that.
Right. Okay. Well, now Laura Salisbury is saying, what sacrifices could have been made to the design in order to achieve LETI targets? I think that's another one for you, Francis.
I think we might be on the same vein here. In terms of other sacrifices, I mean, the LETI targets, that's to do with the embodied carbon as well. So I don't know whether anyone else from the design team might want to contribute on that. On the operational side, as I've said, I think a lot of this is about how you choose to operate your building.
From our perspective, Peter, obviously avoiding a basement would have saved a lot of embodied carbon. So on future projects, it would, really be good if we can look really carefully at the size and depth and the requirements for basements.
I mean, could I just add actually, Peter, to that the project was used as the basis for a UK GBC study into the technical and financial viability of net zero carbon, which looked at both operational and embodied targets as a trajectory, as most science-based trajectories are. And it took what we called a baseline, an intermediate and a stretch scenario, which was looking to the ultimate targets in 2035 and explored how a project could get to that ultimately. Quite a lot of the operational evidence from that was fed back into the scheme, so particularly around cloud computing and reduced small power type issues, and that has really fed back in, and we're very, very close under some scenarios to the 2035 targets. And as Dee said, I think that the principal change that would be made for embodied carbon to hit those targets, I mean, we're well below the trajectory towards that, and it's under half what a conventional office building of this nature is already. But to get to that is probably looking at full timber structure and no basements. And at the time, I think that there was a full timber structure of that scale was seen as probably a step too far. But that may be one of the next projects to come along, hopefully.
Thank you. Now, Janet Morris is asking, there was a reference to roof terraces and balconies. How key is that to the overall brief? And will these only be available for people working there, or will there be any public access? Also, how does the public realm aspect fit into the sustainability models? Who'd like to tackle that one?
I'll tackle that if you like, Peter. Just to say that the terraces will be for the use of the occupiers of the buildings, and there is optionality around whether they're available depending on the leasing strategy and the way that the buildings are occupied. That the terraces fall into two groups really. One, terraces for individual floors, And then we have a communal roof terrace at level 10 on the east building, which could be available to everyone in that building. The public is really served by a generous public realm at ground plane, which been carefully designed by Barton Wilmore, our landscape consultants on this scheme, to provide connectivity and to open up what's currently an impenetrable site. And it will be very green. You'll be able to sit within what is effectively a pocket park. So it goes back to what I was saying about the initial brief, that wellness is sort of embedded in the brief, and greening areas within the scheme is an essential part of that.
Thanks. Anybody else want to add to that? No. Okay. We've got a couple of comments here on the fire testing. Dimitri Stoffer says, has this set a new precedent? Are the results available to use on other projects to prove fire integrity of CLT, or should the testing be repeated every time? That's one. And then Laura Lamont is saying, great to see a test for fire integrity. Are you finding this is now normal strategy for specifying CLT as this has become difficult? Do you think standards will come in line with these findings, as this will have an impact, albeit perhaps small, on the carbon credentials of these projects if every project requires testing flammability for different scenarios? So quite a lot of interest in your fire tests, Francis. Do you want to add to it, and anyone else want to come in there?
No, I'm happy to add to it. We've just clarify, I'm not a fire engineer, so but I do believe that, I mean, with the testing, it was done for confidence. We'd already calculated I say we, fire team had already calculated what was going to happen, but this was about the nervousness that you have around building it from wood. So that fire test was for this building, this particular structure. So that fire test doesn't therefore prove every project. But I think as fire tests are done for buildings, then it builds confidence that what you do on paper actually is reflected in real life. And yeah, it could be the start of better confidence in the industry.
So somebody else, Rob, has asked, does this impact on the insurance for the building? Do the tests reassure your insurers that the building shouldn't be surcharged for its construction?
Well, I have to say we still don't have London Fire Brigade approval. We're still in that negotiation, but with the data that we collected and the practical exercise of the fire test, we're taking the fire brigade and the building inspectors on a journey with us, and I believe we are making great progress in that respect. This is a pioneering development, and it needs to be seen in that way. It's a reflection of our confidence in finding a solution that we're proceeding in this direction.
Thanks. Now, Ashley Bateson has asked, Rob, do you see a lot of tenant demand for sustainable offices at the moment?
Yes, I mean, demand is difficult to gauge because we've just been through a particularly unusual period, and we're coming out of that. But I do think that the pandemic's given people time to reflect on the type of offices they're going back to, in addition to which legislation, public mood amongst employees has all shifted. And so, yes, occupiers are looking to meet their sustainability aims with the buildings that they look to occupy, and we're trying to make it easy for them. We're trying to become to make it that sustainable buildings are the buildings of choice, and I think we're pushing very much with the tide in that respect.
So also somebody's asked, and maybe Peter, you could respond to that, whether adding on to that, are more clients pushing for net zero buildings? And are you finding that now amongst people who come to you, that they're ready, primed to do that?
I think a lot are, and that there's been a huge uptick in that as a key factor when people are coming to the likes of ourselves at the moment. I think that's been really marked and significant, and it's worth actually just on commercial occupiers thinking about. I think in 2017, less than 10% of the FTSE companies had science-based targets, and it is now well in excess of 50%. And I think in London, there's something in the order of 20 million square feet of occupied space that has a lease event in the next few years that is currently occupied by companies with science-based targets. So I think that is going to just keep on coming more and more.
Very interesting. Yes. So this one to HTS, I think Stephen King says, how did you balance the decision between smaller structural grid and fully timber construction, or larger grid and hybrid steel construction, and were the benefits for carbon and flexibility?
Yeah, thanks. Really interesting question. I think when you're looking at spans of, say, more than 9 meters for the beam, and in this case, we're at 10.5, 13.5 meters in some locations, timber beams become very, very large. You can't get many services through them, and you end up making the building a lot taller to account for that. So you might lose 2 or 3 floors at the top of the building for a high rise such as this. So that is the main challenge, really, which is one of the reasons why we chose steel beams in this occasion. The same thing with columns, really. Timber columns can get very, very large at the base of high-rise buildings. So, that is the main thing, really. It's space and its height. It's undoubtedly fully timber building would be a lot better from a carbon perspective. Steel does have a lot of embodied carbon within it. And we are proposing fully timber buildings on other schemes. On this particular one, it was just decided to be slightly outside of our reach at the time. So it's definitely possible. The carbon benefits are great. However, you'll get less floors for your money.
Right. And I'm not sure whether this is one for you or for Peter, but have design for disassembly on circular design employed, and if so, what are the strategy? And so.
Well, I think I said actually during the first slide that one of the most exciting bits of the brief to us was visible and reversible structural connections, and that implied an understanding of what that meant visually, but also that the building could be dismantled if need be. Albeit, I do have somewhat of an issue with this, in that I think what we should be doing, a really circular building, is just one that is reused as a building, as opposed to one that is dismantled and reassembled, or components reassembled. But a really important part of that ability to reuse buildings is adaptability. And in this case, the structure is not composite. So the steel frame is the stiff bit, and then the planks are almost literally just laid on top of the beam. So they can be unscrewed, they can be lifted up, they can be moved around. Now, that's one of the points that Dee was actually referring to, about the amount of work that is done often on fit outs to form new openings and soft spots, whereas in effect the entire building is one massive soft spot, and they can literally just be unscrewed and stored in the soffit if need be.
Very good. But as a practice, you're great supporters of long life, loose fit then for buildings, are you?
I think that's got to be the first mantra. I mean, we should be first and foremost designing buildings that are adaptable and can be reused as buildings where they are. And disassembly is the next tier after that. For most buildings, I mean, there's certain types of buildings that will inevitably have short lifespans, but by and large, we should be designing almost use agnostic buildings that can be reused in many, many different forms.
Absolutely. Very good. Well, that's a jolly good comment, I think, to end this. We're just about up to time, but very exciting morning, and great to see those fire tests. I think that good to reassure people that actually timber is a very good building material, despite some of the feelings that timber is not as good as some of the other materials, when in fact it is actually enormously efficient. So following the science, I think, is great in construction as well as in pandemics. So thank you all for your contributions, and very interesting to look at this new innovative project, and good luck with leasing it, Rob, and thank you all very much for being here and everyone attending this morning.